Today we're going to be talking about the Pythagorean theorem and its converse. So first of all, when we talk about the Pythagorean theorem, this should be mostly a review. Remember that our Pythagorean theorem says that we can say a squared plus b squared equals c squared. Okay? And we know two things. First of all, we know that a and b have to be the two legs of the triangle. In other words, they cannot be the side that is across from the right angle. They're the other two sides. It doesn't matter which of the two sides is A and which of them is B, just that they have to be the two legs. And then we know that C squared, or C, has to be the hypotenuse. Now remember that the hypotenuse, okay, is across from the right angle. So you can think of your right angle as being like a little arrow. It's pointing you to the hypotenuse. So you know that this side has to be C. Okay? And we can find any of the three sides of this triangle if we're given the other two. So it doesn't matter which one we're given. We can just plug in our numbers. So we'd have 4 squared plus 3 squared equals C squared, because C is the side that we are trying to find. Okay? And we would go ahead and we would solve this. And so we have 4 squared is 16, and 3 squared is 9, and we would add those together to get 25. And then remember that to get rid of the squared over here on the C, okay, we have to take the square root, because the squared and the square root will cancel each other out, and we will just be left with C. And then the square root of 25 is 5. Now, if it had been some other number that was not a perfect square, remember that you would need to go through the process of simplifying your radical like we did in 8.1. Okay? Also, if you forget about how to do that, we also covered that back in chapter 0, so you can go back and look at the chapter 0 lesson on radicals. Okay? So we know this side is 5. All right? What about if it's not the hypotenuse? This is one of the areas that we have made the most mistakes in so far this year. So we still have our two legs, our A and B. Okay. This time, one of the legs is the side that's missing, right? And our hypotenuse is still the side across from the right angle. And this time we have that number. It is 13. So we're still plugging this into the same formula. And we want to be sure that this time, since we have our hypotenuse, we have to be sure that gets placed in the C location. Okay. And again, which leg is A and which leg is B does not matter. So if you had A squared plus 5 squared on the left here, that would be fine. Okay. Our next step is to go ahead and square each of the numbers. And when we do that, okay, we end up with what should look like a pretty normal algebraic equation at this point. So we're going to subtract 25 from both sides. And we get 144 over here. And all that we have left on the left-hand side is b squared. Okay? So again, we want to get rid of this squared. So we're going to take the square root of both sides, because squaring and square rooting cancel each other out. So we just have b left. And on this side, we have 12. Okay, so now we know this side equals 12. Okay. So again, I'm giving you two examples here. One is an example for how to find a leg, and one is the example for how to find the hypotenuse. Okay, and you're going to notice that both of these examples, we'll go back to those, have been whole numbers in each location, right? So this one, our side measurements of our triangle are 3, 4, and 5. This one, it's 5, 12, and 13. And those are really special numbers. Okay, so a Pythagorean triple is going to be a set of 3 numbers. And what it's really saying is that if you use these 3 numbers, they could be the 3 sides of a right triangle. Okay, so that's kind of where it gets its name, a Pythagorean triple. Okay, the official definition is that it has to be a set of 3 numbers They have to be whole numbers, so they can't be decimals. They have to be non-zero numbers, so you can't have the number 0 as any of the numbers, okay, because that would mean that the side of the triangle did not exist. And they have to be able to be plugged into Pythagorean theorem, and they have to work. So we say they have to work in the Pythagorean theorem. All right? So, if you look in my classroom, over on the left side of the room, there is a green poster board that actually has a whole bunch of Pythagorean triples. You can also find a whole bunch of Pythagorean triples in your book at the bottom of page 548. Now, why are these so special? Why do we need to know about them? Most of all, they make your life much easier, right? If you are given a triangle like this and they tell you this side is 3 and this is 4, and you know your Pythagorean triples, you don't actually have to do any work. You can just know that this hypotenuse has to be 5, okay? They're also going to help us figure out some other exciting things about some triangles, and so that's going to be really helpful. So you don't have to memorize all of them. I would start to notice them and pay attention to what the most common Pythagorean triples are, like 3, 4, 5, and 6, 8, 10, because they will save you a lot of time and energy, okay? You also need to be able to tell me, if I give you 3 numbers, are they a Pythagorean triple or not? That's going to be really important. Okay, so now what about the converse of the Pythagorean theorem? So the Pythagorean theorem says that we should be able to take 3 measurements on a right triangle and plug them in to this formula, a squared plus b squared equals c squared, and we will always get a right triangle. Well, we can actually turn that formula around, and so you're going to notice I've got the Pythagorean theorem here. I have c squared is in the first location on each of these, and that's really important. And when we do that, we are going to know 3 things. We can actually use this to classify a triangle. So first of all, if c squared is equal to a squared plus b squared, then this is a right triangle. And this is just our Pythagorean theorem written backwards, right? That's all it is. If we find out that c squared is less than a squared plus b squared, right? We're talking about we plug in numbers and we get numbers on both sides of the formula here, then we're going to know that this would be an acute triangle. And if we find out that c squared is greater than a squared plus b squared, then we'll know we have an obtuse triangle. Okay? So it's really important that you pay attention to what those 3 measurements are. So they might actually give you a question where they say, can these 3 numbers make a triangle? And if so, then classify this as an acute, obtuse, or right triangle. So let me go ahead and give you 3 numbers. We are going to use 9, 12, and 15. And we have 2 questions here. So let's look at the first question first. So can these make a triangle? So remember, we said before, this is a couple of chapters ago, if we add up the 2 shorter sides, then they have to be bigger than the one long side. Okay, so notice I'm not squaring anything here, I'm just adding. So 9 plus 12 is going to give me 21, and 21 is bigger than 15, right? So that's good. 21 is bigger than 15. So yes, these are going to make a triangle. Okay, that's our first question. Second of all, they want us to classify this triangle as either acute, obtuse, or right. For this one, we have to plug it into our formula we looked at on this previous page. Okay, we're going to have c squared, and then we're going to leave a blank, and we're going to have a squared plus b squared. So we have c squared, and then we're leaving a blank, a squared plus b squared. Keep in mind, your hypotenuse has to be the longest side. So this one has to be the right angle. All right, so we're going to plug that in here. So we're going to have 15 squared, and then a blank, and then a squared and b squared. And it doesn't matter which of the other 2 numbers is a and which one is b. Okay, it'll work out no matter which one you put in each spot. and then we square them. So we get 225 here, blank. We have 81 and 144, and when we add up 81 and 144, we get 225 on this side. Okay? So what symbol would need to go here in between these two numbers? They are exactly the same, right? So our answer is they would have to have an equal sign. Okay? That would mean that these are right. This is a right triangle. Sorry. Okay? So yes, it makes a triangle. The type of triangle it makes is a right triangle. It's really important that as you go through these, you make sure that c squared is first. Okay? That's going to be really, really important. So we will look at some more examples tomorrow in class. And I really appreciate you watching our video. Thank you. And I hope that you have a lovely afternoon. Goodbye.